And this is Mr. Bonet with AP Calculus AB, limits such that find AB such that the function is continuous. Okay, this is very typical for the AP Calculus test where they give you unknowns and you have to determine what their values are, forcing the function to be continuous specifically at a point. Okay, now how do we attack that giving the piecewise function? Okay, so you by now, if you've seen all my videos, okay, you should notice that the points of discontinuity usually are formed on the separation for the domain. Okay, so here notice that x is less than or equal than 2 and x is greater than 2, x is less than 0, x is greater or equal than 0, so on and so forth. Okay, so those are the values for which you have to check if the function is continuous or not. Okay, how do we do that? Well, we have to know that the limit from the right has to be equal the limit from the left and has to be equal evaluated at the point. Okay, all these three conditions must be met in order for this to be continuous. Okay, so that's what we're gonna find here. So on the first one, if I'm choosing 2 from the right, I'm choosing this one, which is x is greater than 2. So in this case, it will be a2 squared, which is 4a. Now, if I'm choosing from the left, I have to equal it. I'm choosing this one, okay? So it's gonna be 2 cubed, which is equal to f of 2, which is 2 cubed is 8. Okay, therefore, in this case, 4a equals 8, which means that a equals, we divide by 4, 2. Okay, so that will be for the first one. The next one, notice that you have this sine of x over x. Okay, now there's a theorem that states that the limit when x approaches 0 for sine of x over x is equal to 1. Okay, that's already been proven. You can use that on the AP test without having to prove it. So how do we approach this? Exactly the same way. Notice that I'm going to erase this so I can have more space. Okay, I'm looking for when x approaches 0 from the left. In this case is g. And that has to be equal to when x approaches 0 from the right. And that has to be equal to g of 0. So from the left, I'm choosing this one. So the limit when x approaches 0 from the left of 4 sine of x over x. Notice that this is equal to 1. This is 1 times 4, which is 4. And that has to be equal to the limit when x approaches 0 from the right. If I'm choosing 0 from the right, I'm choosing a minus 2x. That's going to be a minus 2 times 0, which is a. Therefore, a is equal to 4. Okay. Notice that g of 0 is also the same one, so we don't have to find it. Okay. Now, this one has two variables, two unknowns. Okay. So how do we attack that one? Whenever you have two unknowns, usually you have to do a system of equations, but I don't know. I'm still skeptical of that for this problem. So let's see. So the limit when x approaches negative 1 from the left of f of x has to be equal to the limit when x approaches negative 1 from the right of f of x, which has to be equal to f of negative 1. And also the limit when x approaches 3 from the left has to be equal to the limit when x approaches 3 from the right, which has to be equal to f of 3. So let's start with the top one. Okay. So the limit when x approaches negative 1 from the left is 2. So 2 equals the limit when x approaches 1 from the right. We have to plug it into this one. So 2, oops, not 2. It's a times negative 1 plus b. Therefore, 2 equals negative a plus b. So in this case, we do have a system, okay? A system of linear equations we need to use to solve this. Where do we get the next values for the system? Well, we're going to use the second row, this one right here. Okay, so the limit when x approaches 3 from the left is still this one. Okay, so that's going to be, I'm going to separate those two. So that's going to be a times 3 plus b. And that has to be equal to the limit when x approaches 3 from the right, which is equal to negative 2. So 3a plus b equals negative 2. Now we need to solve this system, just like we've been taught in Algebra 2 and Precalculus. So how do we solve it? Well, there's multiple ways to do it. We can use elimination, we can use substitution, we can use equality. Just by looking at this, I'm going to use substitution. Okay, so I'm going to bring the a to the left, so 2 plus a equals b. And I'm going to plug that into this one. So 3a plus b, which is 2 plus a, equals negative 2. So we add common terms. So 3a plus a is 4a, plus 2 equals negative 2. I subtract the 2. So 4a equals negative 2 minus 2. 4a equals negative 4. We divide by 4. A equals negative 1. Okay? So now we're going to plug in that negative 1 into either or. I'm going to plug into this one. So 2 minus 1 equals b. So 1 equals b. Okay? And that's how you will solve that one. Now for the last one, I'm going to use a different color. I know I'm all over the place here. That's why I'm using different colors. So you identify that this one is for the brown, and now I'm going to do the blue. When you have this, and if you saw my first video, you'll notice this again. When x is not equal to a means that x can be anything except a. That means the limit from the left and from the right are both for the same one. Okay, so the limit when x approaches a from the left and from the right, it's going to be for x squared minus a squared over x minus a. Notice that this is going to give you 0 over 0, so we need to factorize that. So it's going to be x minus a, x plus a over x minus a. Notice that they cancel, so you're left with x approaches a, x plus a. We plug in a, you get a plus a, which is 2a. And that has to be equal, in order to be continuous, f of a, or in this case, g of a. And g of a is equal to 8. So 2a has to be equal to 8. Therefore, we divide on both sides. We get a equals 4, which is our answer. And that'll be all for this video. If you like the video, subscribe to Motivao. Share with your friends who are taking the AP Calculus, and let me know what you think. Thank you.